let's solve some problems on quadratic equations. We have x squared quadratic equations. Quadratic equations are equations of the form x squared plus bx plus c equals 0, where a, b, and c are constants. Okay, they are constants, and so we can, when we say we try to solve an equation like this, we're trying to get the values of x for which this condition is satisfied. In this case, if you find the value of x and make the substitution, you have to get 0. Of course, there are ways of doing it. One of the ways of doing it is factorization method. Another method is we have formula method and completing the square method. So each of these methods will give you an answer to this problem. Okay, we'll just write a simple equation. We use each of these methods to solve the problem. Okay, I have here x squared plus 5x plus 6 equals 0. So here you can see that a is 1, b is 5, c is 6. Of course, as we advance in this, we would know what we call sum of squares and product of squares. Okay, those ones will come later. Let's have an idea of what this thing is. Now, let's use factorization method, we use formula method, and we use completing the square method. Okay, I would like to use this first before this, because you get the formula from completing the square. Okay, now, when you have this kind of expression, the coefficient of the quadratic term is 1. The coefficient of the linear term, linear because the power of x is 1, is 5, and the 6 is a constant. So you look for two numbers whose product is the constant term, and sum the coefficient of the linear term. Okay. Now to do that, you multiply the constant and the coefficient of the quadratic term. So that will give us 1 times 6. That is 6. Now you look for the what we call prime factorization in mathematics. You keep prime factorizing 6 until you have two numbers whose sum is 5 and product plus 6. Okay, we try 2. 6 by 2 is 3. 3 and 2 would give us 5. And so instead of writing 5 here, we replace it with 3x and 2x. So that would be x squared plus 3x plus 2x plus 6 equals 0. Okay. Now you usually we group them in 2s. Okay, and look for the what we call highest common factor, HCF. The HCF you were taught in primary school, you apply here now. So the highest number that can divide it to is what HCF means in the common parlance. So that would be x multiply and divide by that same term. Okay, and so 3x you divide. Okay, the reason is that if you open this bracket, you get back the same thing. Okay, between 2x and 6 is 2. You have 2x divided by 2. 6 you divide by 2. What does that cancels x? Okay, now we have x squared over x is x plus 3x over x is 3 plus 2. 2x over 2 is x. 2 over 3, 6 over 3 is 3. You see, x plus 3 is common. Okay, these are two terms. Term 1 is this. Term 2. They have a common factor. There's a factor, there's a term, there is a term that can divide both. The biggest term that can divide both, or what highest common factor is, or greatest common factor is x plus 3. So you have x plus 3. Bring it out, you have x plus 2 equals 0. So if the product of two terms is 0, it means each of the terms, either one of the terms is 0 or both terms are 0. So what it means is that x plus 3 is 0, in which case x becomes minus 3, negative 3, or x plus 2 is 0, x becomes negative 2. Okay? That is using factorization method to solve this problem. Okay. They use completing the square method. I hope that is understood. They use completing the square method. Okay, I wipe here. I'll write this problem here. So first we've used factorization method. We use now completing the square method. Now x squared plus 5x, sorry. Okay, I rearrange this. When I rearrange it, I will have 5x equals negative 6, of course, plus 0. Now, when we say we want to complete the square, it means we want x squared plus 5x to be something of this form, plus or minus squared. You understand? So it has to be, we want it in this form, okay? And equated to something. So this is what it is to complete. In other words, we want to make it a perfect square because this is a perfect square. Okay? It's a perfect square. Okay? Because it's a perfect square because x plus or minus a times x plus or minus a gives us that. Not like 25 is a perfect square. And 36. Okay. Now, if you want to do that, you check the coefficient of the linear term, in which case now it's 5. So it's this plus 5x. You add half square of the half of this coefficient. Now you do the same thing to the right hand side. The reason you do that is so that you don't change anything. The reason is if 5 over 2 squared crosses, we get back our original equation. See that? It goes there, it will cancel out. Now, this can be factorized. So this is exactly x plus 5 over 2 squared. That's what this is. That's what it is. Okay? So that is equal to minus 6, negative 2 plus 5 is 25. That is 5 over 2 times 5 over 2. That gives a negative 6 plus 25 over 4. Okay, that will give us, I don't know whether you're familiar with what we call equivalent fraction. It's making two fractions have the same denominator. But of course, we can just, this is minus 24 plus 25 over 4. For those who are familiar with math. If you're not familiar with mathematics, you can just do this. This is 6, negative 6 over 1. So I can change this. Negative 6 over 1 is something as negative 6 times 4 over negative 6 times 4 over, 1 times 4. See that? This cancels out, I get back this. So it's something as negative 24 over 4. See that? So the equivalent fraction of negative 6 is something as negative 24 over 4. So I will have negative 24 over 4 plus 25 over 4. So since they have the same denominator, I will just add their numerators. Okay? And wipe this. So I have um, x plus 5 over 2 squared equals 25 minus 24 over 4. That gives me 1 over 4. So I'm having x plus 5 over 2 squared equals 1 over 4. Gives us x plus 5 over 2. It's something as if we take the square root of both sides. I'm leaving the answer so that we can compare at the end of the day. Okay, we got x negative 2 and negative 3. Now, we're having x plus 5 over 2 negative square root of 1 over 4. That's what it is. And so that will give me plus or minus half. So I'm having x plus 5 over 2 equals plus or minus half. So it crosses over. X plus 2 crosses over. We have x equals negative 5 over 2 because it's positive. Yes, if the process changes, plus or minus 1 or 2. So they have the same base. So they have the same denominator. So we add their numerators or subtract or add. So we have plus or minus 2 all over 2. See that? 1, sorry. 1. So x becomes, we take negative for instance. That's the meaning of plus or minus. So you do for negative or plus first. Anyone? Negative 6 over 2, that is negative 3. Or, so that is this and this go. Or x equals negative 5 plus 1 over 2. Negative 5 plus 1 is negative 4 over 2. That gives us negative 2. So that's correct. Okay. Now, finally, the class will be very brief. Finally, we look at using a formula to solve it. I wouldn't like to just paste the formula on the board. I'll try deriving it so that we know how to go about it. Okay. Now, we have to do that using, this is the form a quadratic equation takes. And so you can write this as x squared plus bx equals negative c. Okay? Because c crosses, I need the coefficient of the quadratic term to be 1 because I'm using I'm using the completing the square method to derive it. That's the condition. The coefficient of the quadratic term, in this case s squared, has to be 1. To do that, I divide through by a. I will have s squared plus b over a equals negative c over a. See that? Okay. So now we complete the square of this. We complete the square. To complete the square, we add half the coefficient of the linear term. We add half square of the coefficients to both sides. So if we do that, the b over ax plus half of, that is half of b over a is b over 2a. See that? So to be b over 2a squared equals negative c over a plus b over 2a squared. See that? So that if b over 2a squared crosses, these two terms will be out. And so we have back our equation. So that will give us this. Give us, again, okay, we have this negative c over a plus b squared, b over 2a times b over 2a, b times b squared, I got it 2 times 2 is 4, a times a is a squared. I like using a topic we usually teach in grade 7, that what we call equivalent fraction. So to do that, I try to change this fraction and look for its equivalent that has the same denominator as this. Okay, sorry. Okay. Now, if we do that, I will have, what I mean is negative c over a is something as negative c times 4a all over a times 4a. You see, watch out. A will cancel a, 4a cancels out 4a. We'll get back our original time, original fraction. You can look for the LCM of both, which is 4a, but I like using equivalent fraction. So when you, this will be negative 4ac all over 4a squared. Okay, so what, this is something as c, negative c over a. So where I have negative c over a, I put exactly that. Okay, okay, it's called equivalent fraction. Now, so I will have negative 4ac all over 4a squared plus b squared over 4a squared. So since they have the same base, the same denominator, I just add. I have minus 4ac plus b squared all over 4ac, 4a squared, sorry. So I can write this to b squared minus 4ac all over 4a squared. Okay? So I am having s squared plus b over ax plus b over 2a squared equals b squared minus 4ac all over 4a squared. Now this left hand side is factorizable. We factorize it is x plus b over 2a squared. Try it, expand this. You will see you get this. We've completed the square. We've completed the square. We're having b squared minus 4ac all over 4a squared. Okay. Now I can take the square root of both sides. I have x plus b over 2a equals the square root of b squared minus 4ac all over 4a squared. See that? So I have is something as square root of b squared minus 4ac all over square root of 4a squared, which is plus or minus root b squared minus 4ac all over 2a. See that? Okay. The plus or minus is coming from the square root of 4a squared. Okay. So that is it. Now, I have to wipe something. I have to wipe here. So we have from here s plus b over 2a equals plus or minus b squared minus 4ac all over 2a. Now, b over 2a crosses over. It gives us x equals is negative. Negative b over 2a plus or minus square root of b squared minus 4ac all over 2a. They have the same base, the same denominator. So you just add. X becomes negative b plus or minus b squared minus 4ac all over 2a. So this is what we call the almighty formula derived. Okay. Now, recall that this a is the a we have here, this b is the b we have here, and this c is the constant term. Of course, a is the coefficient of the quadratic term x squared, b coefficient of linear term x, and c the constant. And so for us to use this to solve this equation, we list out here, compare these two equations. We see that a is 1, a equals 1 because a is the coefficient of the quadratic term, and here is 1. B is 5. You see that? 5. And C is 6. So we plug them back into this equation. If we do that, we'll we'll have x equals negative b is 5 is negative 5 plus or minus b squared, which is 5 squared. 4a is 1 times c is 4 is c is 6 all over 2a 2 times 1. So that gives us negative 5 plus or minus 5 squared is 25 minus 4 times 6 is 24 all over 2 times 2 is 1. So we have negative 5 plus or minus 25 minus 24 is 1 all over 2. So that gives us x is that negative 5 plus or minus square root of 1 is 1 all over 2. So we have x is negative 5. We do plus in the first. Negative 5 plus 1, negative 4 over 2, negative 2. Then we do minus negative 5 minus 1 over 2, negative 6 over 2, negative 3. So I think we got the same thing from the three methods. So these are the methods of you can also use graphical method in solving it. But we wouldn't go into that now because it will be full of assumptions. I have to do it, use freehand sketch to do that. That would introduce a lot of errors. So we deal with these two methods. I hope this helps someone. Thank you very much. We'll be coming online from time to time. Join us. God bless you. How many hours? For 12 minutes?